Hi class, today we're going to start a new unit on trigonometric ratios. We're going to first recall the trigonometric ratios you've learned so far. You've learned so far what we call the primary trigonometric ratios, and those are sine of theta, cos of theta, and tan of theta. Now I want you to also recall that these trigonometric ratios are only applicable to a right-angled triangle. Now you can distinguish a right-angled triangle by the square drawn on a triangle, which indicates that that angle is exactly 90 degrees. And we also have to make some definitions to a right angle triangle. So if I choose this angle to be my unknown angle theta, given by the symbol shown here, then I know that the adjacent side is the side closest to the theta, and the opposite side is the opposite side. And the longer side is always the hypotenuse. Now using these definitions, I can therefore state my definitions for my trigonometric ratios. My sine of theta is equal to the ratio of the opposite side over my hypotenuse side, which can be shortened as such. Now my cosine theta is equal to the ratio of the adjacent side over the hypotenuse side. And last but not least, the tangent of theta is equal to the ratio of the adjacent side over the opposite side. So these ratios are what we call the primary trigonometric ratios. Now, recall that we are dealing with functions, so we need to define all these characteristics as functions. And if you recall, a function is where we put an input, such as our x, and we put that into the machine of the function, or the equation that defines our function, and that gives us a specific output. Now when we deal with trigonometric functions, our inputs are our angles and our outputs are our ratios. So what that means is that when I put an angle into a specific trigonometric function, such as sine or cos or tangent, it should give me out a ratio. So let's do an example. We have sine of a specific angle should give me a ratio. So if I punch into my calculator, for example, the sine of 30 degrees will give me an answer of 0.5, which can be written as a ratio of 1 over 2. Think very carefully what that 1 over 2 means in terms of the ratio in the triangle that we drew above. Now the inverse function, something we've also learned, is where we now switch our input and output. So our input is now the ratio and our output is the angle. So if I put my ratio into my inverse function equation, it should spit out my angle for me as my output. So if I do the sine inverse, remember, of a ratio, I should be able to get my angle back. So our example could be, following the example before, the sine inverse now of our ratio, which was 1/2 or 0.5, I would get my angle back, which was 30 degrees. So think carefully what the ratio and the angle versus the input and the output when you're dealing with questions. Good luck.